As long as that sound.
Just like the pictures and the graphics. You mentioned the flat. If you mentioned the 29th when TV fell, we have a chance.
All right, let's get into it. Dividing complex numbers. The last operation we need to look at to put our whole complex operation set together. We've done adding, subtracting, multiplying complex numbers. Now let's get into dividing complex numbers. Really no more difficult or no more different than multiplying. When I divide complex numbers, it's really going to be a multiplication question, and I'll show you why.
Is that like with is it like with
You
fractions?
flip the double.
With fractions, you have to change it to like a multiplication one.
Oh.
Oh,
Okay.
that's fun.
4 plus 5i divided by 3i. I have a complex number on top, 4 plus 5i, and I'm going to divide by another complex number in the denominator, 3i.
Do we treat it sort
Oh,
of
do
as
you
a
take-
variable?
Now I want to change 3i into a real number. It's a lot easier for me to divide by a real number than an imaginary number. So let's make use of the fact that what is I squared really equal to? Negative 1.
Well, why is it squared?
It's not squared yet. I'm going to make it squared. What do I have to multiply I by to make I squared? I. So let's multiply times an extra I to the top and bottom. I'm going to multiply 3i times I, because then that's going to turn into a real number, isn't it? 3i times I is 3i squared, which we know is going to be a real number. Because I squared is really just negative 1. If I multiply times I to the denominator, make sure you multiply by I to the numerator. Both the 4 and 5i need to be multiplied by I as well. 4i. 4 times I is 4i. What's 5i times I? 5i squared, or yeah, we're going to say negative 5. We'll do that in just a second.
Yeah.
On the bottom, 3i times I is 3i squared. Now let's simplify the I squareds.
Negative
5i squared is really
Negative 5.
negative 5. Now I'm going to put the real part first. I'm just going to put negative 5 before the 4i, because in standard order, imaginary numbers have to have the real part first.
Okay.
5i squared becomes negative 5, so I really have 4i minus 5. I'll just switch that around and put the real part before the imaginary. What's 3i squared equal
Negative
to?
9. Or negative 3.
Negative 3. Now I'm going to write this in standard form by dividing the negative 5 and 4i each by negative 3. Negative 5 divided by negative 3 and 4i divided by negative 3. What's negative 5 divided by negative 3? What's going to happen to those two negatives?
Make a positive.
If double negatives cancels out, let's just call that 5/3. 4i divided by negative 3. Can I simplify 4/3 down any further? As a fraction, does anything divide into 3 and 4? No. So let's just call this minus 4/3. Really all we're doing in division of complex numbers is making it a real number on the bottom by multiplying times an extra I.
Ever be able to combine the fractions?
Not really, because wouldn't one be a real part and one be an imaginary part? And those would be unlike terms that you can't combine. Yeah, you see how this is a real value, this is an imaginary value. I can't combine them because they're different terms.
So you can't add imaginary numbers.
I can't subtract and add real numbers and imaginary numbers because they're different terms, Luke.
But you can multiply.
Yeah.
Okay. That makes sense.
I can multiply x times y and call it xy.
dark.
It's just cloudy.
It's never winter, so it's not winter yet.
Yeah, that's what
It's still fall, winter happens December 22nd.
Okay, let's try another one. 3 plus 5i.
Oh, it's Monday, December 21st.
Okay, I'm gonna keep teaching. Could you please finish your conversations and focus on what's going up on the board, so that I don't have to re-explain myself 10 different times for people who weren't listening in the first place. Okay. Pay me the respect of listening as I'm trying to explain something. 3 plus 5i divided by 2 plus 4i. What's different about this particular division question than the one we just looked at? What's it? So there are two different pieces, two different terms on bottom, both a real part and an imaginary. I'm going to make this a real number, but it's going to take a little bit more work. I'm not going to multiply by just I. I need more to make this a real value. When I was multiplying 5 plus 3i times 5 minus 3i, what did I get out when I multiplied those two together? Just 34. Because what's going to cancel out? Because why? Different signs, same stuff. Same numbers, different signs. So let's multiply by what's called the conjugate. What's the conjugate of 2 plus 4i? 2 minus 4. I multiply that to the bottom, do the same to the top. I have to switch the sign so that I multiply 2 plus 4i times 2 minus 4i. It's just going to be a real number. This is called the conjugate. Complex conjugate. When I take a number times its conjugate, it's going to cancel out to a real value. So really all I'm doing in division is just more multiplication. Does that make sense? You can multiply, you can also really divide. So let's start distributing. It's going to take a little bit of work because I have to multiply the top pair together as the bottom pair as well. So 3 times 2 makes 6. 3 times negative 4i is negative 12i. What's 5i times 2? Okay. What's 5i times negative 4i? 20i over them.
Square. Negative 29 squared.
That last pair is always the trickiest because you got to do 5 and negative 4 as well as I times I. Now when I multiply 2 plus 4i and 2 minus 4i, this is where a lot of stuff's going to start canceling out. Why is it going to cancel out? Opposite signs, right? 2 times 2 is 8. 2 times negative 4. What am I saying? I was looking at the next one.
I'll say.
2 times 2 is 4. I was thinking of the next one before I written it down. 2 times negative 4i is negative 8. 4i times 2.
8i.
4i and negative 4i is negative 16.
I squared.
Let's simplify the squares. What is negative 20i squared really equal to? Positive 20. So I'm just going to kind of erase that or cross that off and put a plus 20. I know right away that that's just got to be 20, so let's just call it 20. Okay, good. What's negative 16i squared?
16.
16. Now let's start combining stuff. I have a 20 and 6 to add together. 6 plus 20 makes 6. negative 12i and 10i
He said
minus
6 plus
2.
20, not negative 6.
What's going to happen when I start simplifying the denominator? What I have on bottom
It should just be regular.
cancels out, right? And didn't I want it to? I kind of designed it that way. I switched the sign from 2 plus 4i to 2 minus 4i so that these two imaginary terms are exactly the opposite and cancel out. All I have left now is going to be a real number. 16 and 4 is 20. Just like I got a real number in the denominator when I multiply by I over here, now all I have left is a real number when I have my denominator in this vector. Questions so far?
What do next?
What do we do next? What did we do over here next? Split it up, because everything needs to be divided by negative 3. Now over here I split it up, but everything needs to be divided by 20. So let's do 26/20 and negative 2i 20ths. Can I reduce any of those fractions?
Yes.
I think I can, right? Because aren't they both even? 26/20 becomes 13/10. 2/20, 1/10. So minus 1/10. Minus 1/10 I. What are your thoughts, guys? Ready to try some practice on your own? Yeah, go ahead, Helen.
So in your final answer, you did 13/10 minus. How do you know it's minus?
The sign right.
Okay.
Negative 2 divided by 20 is a negative divided by a positive. So whenever my final answer needs to be negative. Or divided by negative 3, that's a positive divided by negative, so that's going to be negative whenever my final answer will be.
Okay.
These were both negative, so what's going to happen with that?
It's gonna be positive.
So watch your signs. Double negatives cancel out, one negative make it negative. Grab your practice packet from last week. Let's get some more work here. Oops, that's not it. Complex numbers practice should be a packet where the first page looks something like this up on the television screen. Do you need one, Brooklyn? I might have some extra here.
I'm gonna check my.
Let me know. I have it.
Yeah. I should probably do that. Why are you going to stop the
You know, the world's best place.
I can't find that. Yeah, another one.
Donnie said that to you?
Everyone, right now, let's try a couple here together in class, just so we have some more practice on some of these questions.
Never mind, I found mine.
Would you try number 9 and number 10?
Number 9 and 10. Number 9 large.
The two that I've got highlighted right here. 20 minus 4i, all divided by 3i, and 4 plus 2i, all divided by 5 minus 2i.
Is it okay if I do the working?
Yeah, there's not a lot of space on there, so maybe you want to try your own paper or off to the side somewhere. Mm-hmm. Let's run it out. We've got 20 minus 4i, all divided by 3i. This is really a multiplication question in disguise. What do you multiply to top and bottom? I. Just I. Very good. Just an extra I. Multiply top and bottom times an extra I. Division questions are multiplication questions in disguise. Bro.
Scares me.
Bro.
actually, sorry, I said browse.
On number 10, we have 5 minus 2i in the denominator. And what would you have to multiply by there? Let's see, numbers 9 and 10. Should be these answers here.
Oh, yeah, actually got that one right.